So just to get started, I'm going to do a little image description. I will have captions on, hopefully. So I'm a white person. I have long hair pulled back in a ponytail. I'm wearing a paisley shirt and jeans. And today in this presentation, there will be some moving images. There won't be any strobing lights, but some things that could cause vertigo. If you feel sensitive to that, please close your eyes. And also there will be no sound included except for my voice. Okay. So my name is Elena Sabinson. I'm going to be going over some of my older work from about 10 years ago, got me started in HCI and design, robotics, and then the work that I've been doing over the last 5 years, and then what I'm up to now as a new faculty member right across the way in environmental design at Boulder. So the name of the talk is Support of Soft Robotic Surfaces, including soft fascination, nature-inspired design, self-soothing behavior interventions, and environmental fidgets. I try to confuse you with as many words as possible, so your expectations are all over the place, and I can maybe meet a couple of them. All right. By the way, to the people on Zoom, I can't see the chat, so if you have a question, feel free to interrupt. See, this always happens, right? When I'm about to go, it stops working. All right. Yeah. We're out of a clicker, so I'll have to.
Wait, but it was working.
I know. Well, I'll make it happen. Okay. So about 10 years ago, I was working in a lab called the Design Futures Lab, and we were trying to figure out how are these robotics that are coming into our system affecting us and our sense of ethics and empathy. And our theory was that we're having more and more interactions with things that we just assume don't require empathy. And so because of that, we actually start behaving in such a way that we assume things don't require us to think about them. Questioning, what if we took...
Sorry.
What if we took an alternate kind of approach to robotics, and they weren't about solving some sort of practical issue or making something for us? What if we're just designing poetic robots that have a hobby? What would they look like? And actually, we spent most of our time taking care of them. So we came up with a proposal. It was called Nurturing Emergent Synthetic Life, and we were envisioning a habitat for non-humanity. So in this habitat, there were these nurturing little robots called nestles, and they got to go around this landscape that was built just for them and plant salt crystals that were very ephemeral, and they had these breathing bladders. So the pools would fill up with water with the salt crystals, and I'll show you some more of this. And then as they filled up, these crystals would grow. There's an example right now, and they would make a living landscape that's kind of like nature. We were really also interested at the time, gestural programming was a lot of interest was happening in that. And we were not interested in gestural programming for its technical purposes, but what happens when you use gestural programming internally to you? Like, how different is it to associate or to affiliate with a robot when you're just doing a text-based programming versus when you are embodying those same movements and you have to do them to make the robot do them too? Does that reinforce empathy? Does that make us have some sort of understanding of what it might be like to be inside the robot, and also what the robot might be looking like? So 3D printing was all the rage back in 2014. We were working on these integrated links of robot skin. We were building at full scale. So this is a 20 by 20 foot working live section of the breathing prototype with pneumatic air and copper piping inside. It was all CNC routed using bioinformed aesthetics, so looking at real nature and then modeling things after that and building them in real life. And then we made a film, which I'll show you some clips of. I always think this is like the most hypocritical part of me. Like, I'm all about empathizing with the robot's experience, and here I have them like completely exposed in their most vulnerable state. They don't have their skin or clothes on. And I think about this every time, but in a very human fashion. I continue to show the slides. So I don't know what that says about what I learned from this project. But so this resulted in... Will we play? I guess I got to press those too. The making of a 5-minute film where we documented the breathing landscape. And this was one of the biggest surprises of the project. We were all focused on these agents, these robots who go around plant crystals. And some point during the project, we were like, I'm kind of more into the landscape than the robot. We love this breathing movement. The robots, they were these rigid robotic arms. The weight of their suits was almost too heavy for them. So they were kind of making this very jerky, non-lifelike movement for our nature-inspired project. And all of a sudden we said, this silicone is doing something really beautiful and much more evocative. Let's see, can I get to the next slide? Here we go. Here's a little bit of a time lapse of what the crystals look like as they're growing. They're basically potassium salt crystals. We kind of hacked a childhood game. You maybe have grown some of these salt crystals in your youth. And then thought about kind of color, how the robot can start to make aesthetic choices. We were kind of speculating on mechanical Turk workers, giving the robot information about which colors to be populating, which seeds to plant where, and how to kind of have this living and yet not living in any way landscape that was helping us understand how to empathize with robots and non-living agents. And then we kind of, again, speculated on this 2D overlay, and there's the jerking of the robot, as you saw, there's those real eyes, and then we kind of ended with this very strong manifesto of robot empowerment, where the robots come and clasp their hands together. And here's this baby nestle. That was also a really interesting one. So the nestles needed to have this arm, this mouth, the gripper, we called it, to pick up the seeds and plant them. But everybody loved the one robot we had. We had 3 that had nothing, it couldn't do anything. It had a gripper, it couldn't move, we didn't put wheels on it. It just kind of like went and like oddly moved and jiggled, and that was everyone's favorite robot. All the ones who were performing crystal work, they were like, we don't care. So that was also a really interesting moment for us. Like, it's really not the function of the robot that makes us find it endearing, which was really kind of where we started the project, that the function of robots is not necessarily what makes us connect with them. And what do robot aesthetics look like? I started becoming a little bit troubled by the process. So I was very immersed in speculative design, non-human centered design, and I was making really big claims like, this is teaching us how to care about robots. This is how we're going to know how to do this. And then I was like, I'm not testing this. I don't know how this is affecting people. What are we actually taking away from this? And what's actually happening in this research project? What are we learning? So that led me to start the doctoral program in human behavior and design, where we're really focusing a lot more on social science research methods and actually empirically testing the impacts of the systems we were proposing. I worked on a project called Biophilic Soft Robotic Surfaces. This is the dissertation work that I worked on. And we were really interested in the fact that we're all living inside. The quote we hear probably once a week, we spend 90% of our time indoors. Boulder is clearly the outlier in that department. But what happens in these really small urban spaces, and how can we maybe make them have more supportive natural elements to them if we can't actually pick everybody up and put them in a natural environment, or if we choose to continue to urbanize, which for many reasons, it seems like we shall be doing. So we wanted to also support mental well-being, and we chose 2 main strategies. Biofeedback, which is the representation of some physiological data in any sort of other representation, visual, sound, tangible in this case, and thinking about self-soothing behavioral interventions. So how do we teach people how to soothe themselves rather than relying on something else to try and calm us down? There's also a huge body of research that has demonstrated consistently that nature has a profoundly positive effect on all of us. Being in natural environments can not only help us with stress and relaxation, but also increase our ability to pay attention and perform different cognitive skills, which if you're in research, you know, it's always great if you can convince people your research is going to make people work harder and faster. That's the best way to achieve funding. Salt growing crystal robots, questionable. I don't recommend it. So one key concept in this work is the idea of interoception, which is gaining some more popularity. It's the ability to sense your own internal physiological states. So the one that is usually the easiest to talk about is heart rate. And we can think about how this is an indicator for arousal and different emotional experiences. For example, right now, my heart's beating fast because I'm talking in front of a room of people, and that's letting my body know, like, hey, maybe you're a little nervous or something's going on, you need to perform. There are many other types of interoception, hunger, thirst, going to the bathroom. Some of those are really harder to test and talk about. So usually when we talk about interoception biofeedback, we're thinking about heart rate. We've now found that interoceptive inference, the ability to read those signals accurately and reliably and not hearing them too loudly or too softly, is extremely correlated with mental health outcomes. So many neurodivergent people, such as myself, we might experience very sensitive, like really loud signals. Every time my heartbeat changes at all, I'm hearing it. And that's causing me to pay a lot of focus to that and changing my ability to regulate my emotions. Alternately, a lot of neurodivergent people also have hyposensitivity to interoceptive signals. So the heartbeat's beating really fast and the feedback isn't becoming aware of it. So that can cause a lot of problems. One, it's either creating you to become hypervigilant about what's happening within your body. That can cause a lot of anxiety. Or alternately, if you're not getting the information that you are stressed, until that signal is so very, very loud, it is really hard to take a self-soothing act. So if I don't know I'm stressed until I'm in crisis, it's really hard for me to then say like, hey, take a deep breath, because like it's past that point. We're now in a crisis mode. So we wanted to see, like, is there a way through these systems in our environment to maybe give more awareness about that to people? I basically just said that, sorry, I don't have the visual text. We'll move on to the next one. So just to sum up, soft robotics that we have, which are basically pneumatic surfaces filled with interior air chambers that fill up with air, are being hooked up to sensors and can represent the heart rate feedback that we're getting. And that's one of the things that we first started working on. Another thing that we were thinking about is biophilia. There's a lot of different theories on why nature is so good for us. The one that often gets talked about in a design field is biophilia, which is an evolutionary perspective saying, we grew in nature, we've done this for millions of years, it's part of us, it's part of our DNA, we need to be in nature, we need to have these types of interactions. And when we don't, we have an environmental discord that has negative impacts on us. Another competing theory that's not as focused on evolution is the attention restoration theory from Stephen and Rachel Kaplan. And this is the one that really sparks my most interest. They talk about this idea of soft fascination. And what soft fascination is something that captures your attention. It's mesmerizing. You don't have to think about whether it captures your attention. The nature of the stimulus itself is so interesting to you, you can't help but watch it. And at the same time, it's preventing you from ruminating or having negative worry thoughts. And it's not asking you to do anything. Don't have to do math, don't have to remember anything. You literally can just sit there and enjoy. And a lot of these experiences happen in natural environments. We can think about wind through the trees or this kind of rain, snow coming down at you, or cloud watching. And when we have these types of experiences, we often find them really relaxing and also restorative. We feel energized after them. So we're kind of like, can we create a softly fascinating experience? We're very interested in nature because of its associationship with neurodiversity. Nature is really great for everyone, but in particular, neurodivergent folks, such as people who are autistic or have ADHD, see many positive benefits to emotional, cognitive, and even motor sensory experiences. Okay, yeah. So our system can do a few different things. As we talked about, we provide biofeedback, and this is from human and plant users. Why plants? So plants emit an electrical signal very similar to human heart rate that's representative of happening in their external environment. So if you touch a plant leaf, it actually has a little voltage signal that increases when you touch it. And we can map that, and then we can map it to another system externally. Similarly, if you turn the lights on, a plant signal immediately changes. And there are a lot of new systems that are kind of playing around with this, especially for music. But our question was, if we have a really small room, I cannot have the very many plants that my heart desires. Can I have one plant and have one small surface that helps me understand the internal experience of the plant? Does it amplify my empathy and relationship to this plant life? So that was one of our initial motivations. We're also thinking about, can we simulate things that are actually happening in nature, represent them through our system, and does that also have a positive benefit? We looked at ocean wave movement, and then we're thinking about guided breathing exercises, which we all know are really restorative, and then we also translate sound into inflation behavior. My process usually goes through 3 phases. We think about design, what we did, how we fabricate them, and how we can share tips for other designers and researchers to advance their processes. Technical components, what are the different things that we can do with our electropneumatic regulators? How can we build a mathematical model that can be used to make this behavior in this hardware? And then user studies to actually test the systems and explore the effectiveness of them, and then refine the system based on that feedback. So I'm sure in this group, you guys are all very well at that process. So our first paper looked at the system of the plant and human in this little microenvironment. And this is just representative of what figure representation of what I was mentioning before, that in this hybrid space, we have representation of both the plant and human. And our ideal is like, maybe this third thing starts to become like a symbiotic representation of both of us, and that makes connection. We did some very early work showing that using really low cost electromyography sensors, which are usually used for muscle activation, can be used to record plants. A little bit of confusion as to like how much noise was impacting our system, but we were able to get a really really observable and repeatable effect of turning on the lights and seeing the plant respond, and then saying like, okay, this is how we can start to model that. Also thinking about how soft robotics can be made quickly and how they can be visualized. So soft robots are made out of silicone, which is not a very sustainable material. When you're working on research that's trying to tell everyone like how important the natural world is, and then you're actively destroying it, you have to think about ways to maybe make that less of a problem than it already is. And so our idea was like, if we can make these really beautiful renderings that are representative, we don't have to cast a silicone model until we have that feedback and we're starting off on a better place. So we did some really early work looking at different, using GIFs and kind of looking at different representations of what this might be like, and seeing kind of a repeatable pattern that people liked more of the system, but that they didn't like it when it's starting to have too much detail. And we're going to keep talking about the problems with the aesthetics of this system and all the things I have learned about people's discomfort with soft robots. Additionally, we started getting some qualitative feedback on people's in-person interactions with these systems, which at the time we were making green and orange, because I'm like, mushrooms, they're orange, moss, it's green, nature. Doesn't work that way. So people were touching them and we immediately started getting this type of feedback, like really familiar, but also very strange. Or this one I love, a little disturbing, but strangely calming. So there's not that much non-anthropomorphic soft robotic, human robotic research happening. We really didn't know if the uncanny valley was going to be so central to people's experiences in this work, and very quickly discovered that it absolutely was present. But we did still see, I think one thing that was interesting was that people were still calmed. They're freaked out, but calmed. So that's a hard thing to capture, right? And hard thing to process. How is that possible? And then also people started saying the surface was doing what I was feeling. And so we were having people do breathing exercises. This is the first instance of that. Breathe in, breathe out, just follow the robot. And people were saying like, oh, I'm breathing and the robot's breathing, like we're in this together. And that was something that people were responding really positively towards. And additionally, something that a lot of research suggests that when you do something therapeutic, if you feel you have a partner in that, that can often make the work more effective and easier. So then the pandemic hit. We were like, oh, great, we're doing research on living in a confined space and not being able to go outside. This is resonating. We'll keep going on with our topic. Was not intended, but we wanted to start looking at, is ours more effective than something that is not tangible? And when you're in a pandemic and can't conduct in-person research, you have to be a little bit creative about how to represent these things. It was a little bit frustrating because we're trying to get tangible feedback on the quality of the surface, but we settled for making videos of them that were controlled in color and timing, and seeing people, it was a within subject study design. We published this on Roman, we had 50 participants, not too large of a study, and seeing which one did they prefer and which one reduced their stress more. Interestingly, we did pre-post study within subjects, so they repeated the experiment several times, randomized order, so everyone had a different setup. Interestingly, everybody did have a post-intervention stress reduction. So after doing breathing exercises with either condition, they had stress, except when we started breaking things out by their preference group, we started to see a little bit of a different pattern. So for people who preferred the 2D visualization over the robot, they had stress reduction even in the robot interaction. But for people who preferred the robot, they actually didn't have a stress reduction when they did the 2D intervention. Again, very early suggesting and repeating that even though people didn't prefer the aesthetic, or they might have found it a little creepy, that didn't mean it was preventing it from being able to actually perform a stress reducing behavior for them. And for some people, it was actually more effective. We also started to see these really large crossover effects. So those are really interesting because a crossover effect means that if you don't break out by the correct groups, you might actually find no effect because your data points are collapsing. But when we break out by preference group, and so in the green, we're seeing people who prefer the robot, in the black, we're seeing people who prefer the 2D graphic. So this means like, if I liked this, I thought the 2D graphic was way more relaxing. And if I liked the robot, I thought the robot was way more relaxing. Just no agreement. Except for when it comes to co-embodied breathing, everybody felt the robot was a better breathing partner. Also, interestingly, these are some semantic differential scales where you basically have two descriptors at two ends of a line and people have to choose where it lies between them. And we started pulling out some words that are associated with biophilic design and seeing that people who preferred Phoebe really thought it was way more natural than the 2D. So the biggest spread in answers were for people who liked the robot better, and they thought that robot was really organic, whereas people who liked the graphic, they actually didn't perceive the robot and the graphic from being that different from one another in terms of naturalness. So this was kind of another interesting thing, like for people who are perceiving it as natural, they're perceiving the other as less natural. And kind of this tension between like, is this silicone clearly a natural thing, have something natural to it? This is also backed up in the qualitative data where people who preferred the 2D felt BB was gross, unsettling, like an alien. And people who preferred BB started using the words like mesmerizing, which for us, we're trying to make a fascinating experience. Maybe that's onto the right idea. Again, we're kind of moving away from some of our biofeedback work because we couldn't put sensors on people at this time. And so our thought was, can we model this behavior, taking data from ocean wave movement and looking at how the buoys go up and down to make a math model that our robot could then inflate and create? And does that have a soothing effect like our actual oceans do? We made a new, much bigger prototype based on the feedback. We removed any color from the system. Color is now given through LED lights, much more nimble and adaptable and personalizable. It's also now a panelable pattern, so you could create an entire stadium out of this panel, or you can have just one that's at 18 by 33, which is fairly larger from the existing soft robots at that time. So here's our MATLAB simulation. We basically looked at this on this 2D surface and then redeployed it through our tubing scheme, and then saw that our system was able to both catch those frequencies in a mathematical plot, but also visually and qualitatively was doing many of the similar things. One of the biggest differences is the granulation of the pixel grid. So in our MATLAB simulation, we had a lot more ability to undulate. The pixel grid is much more resolution versus ours. It's much more fixed and larger scale, and that caused some things to kind of shift over in 2D space. So that was pretty effective, but we haven't tested it with people yet. And so now we're like, okay, we got breathing behavior, that worked pretty well. We have this new idea for this soothing ocean behavior. Let's see which one's more effective. This work will be presented at HRI in a couple weeks if anyone's coming. Hope to see some people there. So we now did an in-person study with 94 participants. This one was between groups, so we're no longer giving exposure to both of the study conditions. One person's doing a breathing condition with the robot, one person's watching the robot perform an ocean wave movement, and then we have the core control group that we say, sit there, do nothing, please don't go on your phone. So I always feel bad and worse for the people in that group. It's definitely the least exciting. So to measure attention, which is this idea that we were restoring attention like nature was, we use the standardized, the computerized sustained attention to response task, which is very fun. You see a number 1 through 9, you press a button anytime you see a number except for 3. And all of a sudden when the 3 comes on, you have to stop. Now, if you've ever played a game like this, once you start habituating yourself to go like this repeatedly as fast as possible, it is very hard to all of a sudden say 3, stop. And then we mess with you even more. It's a pre-post test. The first time it's a 3, the second time it's a 4 to try and get rid of testing effects. So if you play video games, you totally messed up with my results. You did great at this. Everyone else, not so much. It's not that fun. So this is basically people came into the lab. We have a pre-test measurement baseline for stress and attention. They have one of their interventions, and then we do some post-test. Oh, just to go over the results. We did the go trials where you're supposed to press it, everyone pretty much did the same. The no-go trials, we started to see some difference. They were not statistically significant, although the pattern aligned in the direction of our hypotheses for the attention task. The control group, we're looking like at the median right here. It's basically at 0. There was no improvement. Whereas both of the other groups, the median was approximately the same, and there was minor improvement compared to the control group. Everyone did better on the post test because they had already done it before, but the biggest improvement was between breathing in the breathing condition, and slight second biggest was in the ocean. We also looked at these pre-post stress ratings. We did find a significant difference there between the control and the breathing group, where the breathing group had a much greater reduction in stress compared to the control group, and a minor significant effect between the ocean and the breathing group, but not between the ocean and the control. which was surprising to us and also helpful to us because when we've shown this work, a lot of the reviews have basically said like, well, maybe you're just making a positive distraction. We're like, yeah, that's our goal. They're like, wait, okay, but how do you know it's the breathing versus just the positive distraction? And this sort of starts to help us understand that actually the breathing is way more effective than just a positive distraction without an active behavioral intervention. Behavioral interventions are something that I'm thinking a lot about lately in terms of like the ethics of them. So I'll talk about that at the end if I have time. So additionally, we started looking at, I need a clock, where are we?
Yeah, the clock.
Okay, cool. Additionally, we started thinking about we also did a qualitative study at the end of the experiment. Everyone came who interacted with the robot and gave us a little bit of feedback. And a few different ways that the system impacted people's breathing. So one, people who didn't normally want to think about their breathing suddenly were. And this was not just happening in the breathing group, but also in the ocean group. We said nothing about breathing to the ocean group. We just put this breathing thing in front of them. And so many of the comments said, like, I was trying to match my breath to it. Like that thing kind of looked like it was breathing. And like, I don't know how someone was matching their breath to the ocean because it's a stochastic model. Like that would be probably more stressful than relaxing. Like the thing with breathing exercises is if you need to exhale longer than you inhale. Because if you inhale longer than you exhale, you're actually simulating hyperventilation and increasing your cortisol and jacking your nervous system up. So anyway, hopefully we didn't stress them out. That wasn't on the IRB. But we did have this very particular timing set up for the breathing exercise. And we saw that actually there is some sort of intrinsic association to breathing when you see a system that kind of looks like a diaphragmatic lung in front of you. The other thing was that people felt that they could breathe much more deeply when they had their hand and were physically touching the robot. And that a lot of people were like, well, normally I just kind of like, and like when this was on there, my belly felt like I knew how to expand it. So it was affecting both awareness, also the pace, which we were expecting because that was the goal, and also depth of breathing. Then sensory qualities. So when we talk about soft robotics, people are often saying like soft robots are great for human interaction. They don't hit you, they're not gonna squash you, you can't break a bone, they're totally compliant. But no one's really talking about the ick factor, which we quickly discovered. So silicone, when it expands, often can have a little bit of a sticky and skin-like quality to it. And what we've noticed is that people, when they were touching it, if they use the word sticky, they were about to say something very negative. If they use the word squishy, they're about to say something very positive. People love to squish, they just don't like the sticky ick. And that is a big takeaway. If I teach you anything about making soft robots for humans, think about the actual stickiness in terms of the texture. I was really excited about some of this feedback because as an autistic person, I wanted to make large fidgets for the environment, but I didn't think that people were going to be like really excited about my idea to make large environmental fidgets. But I made this other system and then everyone started calling them fidgets. And that was really, really exciting to me. And I'm like, okay, we're making this distraction. People are enjoying these sensory qualities. So I got pretty excited about that. Another interesting thing was the sound. I'm not showing you any sound with it, but it's very much like when the sound empties and hits. And so we weren't sure how people were going to respond. There was a big novelty effect here. And if I can also make any recommendations to people testing novel systems, is to do a lot of pilot testing to find out the optimal exposure time. We did a 3-minute intervention because for our breathing exercise, 3 minutes is like a really nice time. And we're like, okay, we'll do 3 minutes for the ocean too. Just thought about that way. But in the breathing exercise, people knew what they were going to do and they adjusted much quicker than in the ocean condition. We started seeing all this feedback. I was like, it just turned on. About halfway through, I was like, okay, maybe this is okay. And at that point, we're no longer getting a reliable test like effect because we're mostly testing their novelty of their first impression as opposed to their actual feelings on the system. When we saw this repeatedly in the feedback, at first I didn't like it, then it was okay. At first it creeped me out, and then I enjoyed it. So just something that I found really helpful in my future work will definitely be essential consideration. Additionally, one other interesting thing was that people in the breathing group started comparing it to oceans, which we had said nothing to them about oceans. They're like, sounds like the ocean. We're like, oh, like Like, so, but there is this kind of sound that has this rhythm of the ocean, even in the breathing. So there was just kind of, that was a lucky accident, or I don't know. I don't really know what it means, but something intrinsic that people are associating. This work's a little bit of an offshoot. I presented this at CNC last year. And so I have been in a room for many years working on a dissertation. There was a pandemic. I'm kind of proposing something dystopian, like we don't have access to nature. Let's make breathing robots and put them in people's houses. And there was a part of me that was like, I just want to get outside. And like, I just want to get other people outside while we still can. Like, we're here, we have this nature. Can we actually embed those experiences in a natural environment into our design by having people collect photos of things in nature and then using that to guide the design? So we kind of also had to track them, make these little GIS maps, because we were thinking that if we showed them the map of where they had been, that would help them recollect their experience in nature when they were appraising the robots. And people kind of took lots of interesting things. It was exciting because now we have robots designed after a bone, or a robot designed after a stump, or a shadow, or a print from a goose. We also were thinking about, for people who are non-designers, or for people who maybe have mobility limitations and computer-aided design software is difficult to use, is there a way that we can have a low input and have them participate in this co-design process? So we created a script in Grasshopper that both traces and creates the models for visualization. So it makes a physics simulation and rendering of it inflating, and also creates the fabrication files. So we can immediately export and fabricate this in both CNC or 3D printing, all in one package. And we just need a person to take a photo, they send it to us, the system creates all of those for them automatically. I also had this little side quest where I was like, what if we made 23andMe packages for robots? Would people feel more connected to them? Because we're often getting all these products that have no history. And when we think about things in nature, there's like this assumed understanding of like, this has come through evolution. One, for the different diverse designs they can make quickly, where they basically cluster similar designs, show you a set, but also for like the sense of history we could maybe embed in artificial things. I have to say that the side quest was a bit of a failure. We didn't really find too many interesting effects on that, but if anyone wants to make 23andMe for robots, I would be interested. Okay, so one thing that was exciting about this project is, one, we still creeped people out. Tracing images with no aesthetic guidance seems like a great idea, but like, we do have aesthetic opinions that when you're just randomly uploading things and letting it do the design often get left out. So I don't think that people personalizing their own designs is sufficient to overcome any sense of creep factor from the aesthetics. It really is a bit more complicated than that. I probably should have known. But the thing that I did find out is that with this natural abstraction process, people like it when it's more abstracted. The ones that were very highly representative of the original images were less appealing to people. And I think this quote captures it well. There's something leaf-like to it, and I can still tell it's photo source, milkweed pod, but as rendered, it suggests other natural shapes, a fish at first, and sometimes a mountainous island landform. And so people like this kind of murky middle place where it's not so representative that it's only one thing, but it's natural enough that it can be many things. And so that's, for me, where I aim to hit in terms of making optimal aesthetics that are nature-inspired. We then wanted to prove like, hey, we can actually fabricate this. We also want to add some more natural materials. Maybe if we put wood and the moss and a little bit less alien, trying to bring our aliens down to earth with some earth materials. So this is our newest prototype that kind of came out of that project, with live moss that you can take care of, and 3 different robots that can all act interdependently or together, depending on how you tube them up. And that's, with soft robots, you have like a few degrees of freedom, the original cast and how the internal channels are connected, but also how the tubing is put, and then also how the actually you have 3 things, because also how the regulators are programmed. So between those 3 different things, there's a lot of variety, even in a pretty fixed system. So just a little bit of a shout out to the many amazing grad students and undergrad students who helped me along the way. As you guys all know, none of this is possible without the team effort from research labs, and just want to give them a shout out. So where are we now? I now am very focused on neurodiversity and design, and how fidgets and stimming interact with soft fascination. If you are not nuanced in the language of neurodiversity, stands for self-stimulatory behavior. So everybody stims, whether you're neurodivergent or not. For example, if you're like shaking your leg, why is this line taking so long? Or like clicking a pen, or even snapping some gum, those are all stims. So stimming is not unique to neurodivergent populations. When we talk about neurodiversity and stimming, it's usually the intensity, the frequency, or the style of stimming. For example, myself, I have a very interesting hand. I don't know how to explain that. So yeah, this is my hand stim, and it's something that for most of my life took a concerted amount of effort to mask, and I was taught to not bring into my professional or social environment. And so my question now is, what stimming serves to neurodivergent populations is that it's an energy regulating method. And what happens is it's capturing your attention, but it's not asking you to have any cognitive load, and it's preventing you from ruminating on worry thoughts. And that to me sounds a lot like soft fascination. And so for me, one of the main things that I started realizing is that like stimming and soft fascination, we're talking about as if they're totally different processes for us physiologically and psychologically. And so moving away from soft fascination, I'm now more deeply into stimming and how we can design emerging technologies, products, devices, and systems that accentuate stimming. When we design for neurodiversity, which does not just include autistic and ADHD, I tend to focus on those because those are my neurotypes, but neurodiversity includes any time your brain functioning deviates from what is considered normal by society. It can be that you have mental health issues, you can have depression, you can be dyslexic, you can have OCD. There is no barrier. Neurodiversity, being neurodivergent, is not a diagnosable condition. It's actually a social movement. There are conditions that are diagnosable, like autism, within the neurodiversity framework. But just to be clear, when we talk about neurodiversity, we're really talking about embracing how different all of our brains are, and how we can access and celebrate and provide more equity in all spaces for different types of existence. So my lab is the Neuro.D Lab, Neuro.D for neurodesign, a lot of cognitive neuroscience embedded in my work, Neuro.D for neurodivergent, neurodiversity. I don't know, maybe I'm also like stealing from the Stanford D Lab. I don't know, they might sue me. We have to, this name, I'm shopping this around right now. So you guys are some of my first targets. But some of the main things that we will be exploring are how can we support the nervous system through environmental design, spatial design, and diverse sense. And some themes we explore: stimming, bodies in space, such as interoception or proprioception, which is awareness of where you are; synesthesia, which is experiencing a combination of multiple senses, and more and more we're finding new types of synesthesia. We thought this was like a very rare phenomenon, and now we're seeing it's not as rare as we thought. I grew up, my mom is a color text synesthete, and I have audio visual synesthesia. And more and more I talk to people, I find more and more synesthetes lurking in the rooms. So aphantasia and hyperphantasia, this is really interesting to me from a design sense, because that's the spectrum of ability to visualize within your mind. Some of us are visualizing things, some of us are just having a mental internal dialogue, some of us are visualizing text but not images. And the range of fidelity that those internal visualizations have is very vast. So some people have very accurate and hyperphantasia and some people don't. And how does that affect how we're learning, how we're wayfinding, how we're getting through spaces, how we're talking to each other in a design space, and alternate communication styles. I have pretty low support needs, which means that I'm often given a lot of airtime in the autistic community. Many autistic people and rely on alternate types of communication, such as using alternate and augmented communication devices, or body language, or sounds that aren't necessarily speech related but are verbal. And so I'm also very interested on designing objects and artifacts that decenter speaking and find alternate ways of connecting and transmitting information that helps us feel understood. So that's just a little bit of my future work, and if anyone's ever interested in coming over and chatting, I would definitely be super jazzed to chat and connect with any of you. So thank you. I appreciate it. So questions, if anyone has. Yeah.
So when you were going into the breathing and touching and getting sensory responses, you were then getting this ick or whatever factor. was there ever a time where you said, think about X, either think about nothing or think about
Mhm.
an animal or think about something, and then what reactions you would got from that kind of prompt?
No, I love the idea of doing a priming study and seeing how that affects interpretations. It's not something that we've done. We've been operating under the we want to get the most neutral data on this. What happens? What can you tell us about it? But I love what you're suggesting and how that maybe connects some of the later work about forms and how we maybe could prime people through those visuals to see how that might affect things. So thank you. That's a really neat idea. Yeah.
Did you ever consider any kind of telepresent versions of your soft robotic project? So if connecting some moving thing to like real world data, like the actual waves when they're happening or plants in a rainforest, if that would have some other kind of effect on participants if they know that that's what's happening?
Yeah, I would also be really excited. We started thinking about oh, if we put this in a lobby, there would be very different interactions that we would want to take place. There's not a lot of studies on biofeedback in public settings, but what we do know is that people feel really vulnerable, oh, you can see my heart, that's scary. So thinking about in a public setting, how we might do different types of behaviors that are more immersive and open-ended and less private would be a wonderful suggestion that I love. I think probably the closest thing we've done to that is the ocean wave data set and our music representation. So I didn't show any of the music work just because it hasn't been formally tested, but we're doing a lot of sound-based stuff now. So you can either in a microphone say something, it hears you and responds, or just upload a music file and then it basically creates a rhythm and does a little bit of an inflation dance with it. I'm not too happy with the nuances of the behavior yet. So as soon as we, as soon as we get those operating a little bit better, there's a bit of a lag with the air. And so one of the biggest problems with this system is how to deflate it quick enough when you're doing input signals that are happening too rapidly. And we have that problem or that limitation with the ocean wave algorithm and also with our music. So it works really, really great for mid beat per minute, but really, really fast. And it's just inflated the whole time. And I'm that's not great. So we're still working on fixing that now, but I think that is maybe speaking to the essence of that type of interaction. Thanks for the suggestion. Yeah.
I guess my mind goes to if I am neurodivergent, but I want some kind of stimming in a public setting, like a covert wearable or something that can be under my shirt. It could just soothe me in public, so no one would know that it was doing that, but it would just kind of, I don't know, inflate or move in some way. Have you thought about that or?
I've thought about that, and there are some people doing really exciting work in that domain. My interest is destigmatizing that behavior, and therefore, for me, what I'm interested in is publicly creating more celebration around stimming and not making it a private thing that has to be hidden, because that's been so often what I've been told. So I think that that's a very valuable thing, and for people who want to be able to do that in a controlled way, they should absolutely have access to that technology, but it's not my main priority or interest. Yeah.
Yeah, you mentioned that silicone, and the environmental effects of that material. I'm just curious if you've explored biomaterials or if that's something that you're interested in.
I'm very interested. I've explored it not through soft robotics. I've done a lot of SCOBY-based fabrication, but the elastomer issue, I have not found one. I always am alginate seems like it could be there. And so if there are new developments in the flexibility and elastomer stretchiness of those, I will be right on there. And I think, I'm not stuck on I'm only doing soft robotics for the rest of my life. I love the material and it's one way to do this, but if we can find bio-based materials that also provide opportunity to celebrate stimming, I'm so jazzed about that as well. And would love to be in parallel progressing in that area. Yeah, I'm just waiting for that, stretchiness, but there's probably a different way of fabricating, the molds. Anyway, you have me thinking again, what maybe the chambers are different. And so hit me up, let's do it. Yeah.
I'll complete the back row. I just wanted to ask you, generally speaking, tactile versus audio inputs to the human mind are pretty similar, but they're not the same. And just curious to know, how much would you sort of be able to start a parallel path that's just audio? And I also just wanted to throw something out before you answer that question. There is a company that I know of that has essentially using Wi-Fi technology, the ability to pick up, I'm thinking of the 5 gigahertz band, motion and if somebody, you could actually probably get it to do become a stimming sensor.
Yeah.
And then you could hook up to audio, create rewards, or impediments, but that's something that you could easily do very inexpensively. Just would take a little bit of software.
Yeah, I love that idea, and I'm really excited to think about how the environment as sensor can be expanded past the ones that are just body-based or kind of attached to the robot itself. So I think you're suggesting really
In a public venue,
Mhm.
public space, that's a really neat way to introduce it.
Yeah, thank you for that. I would be very excited. And I love what you said about the relationship between touch and sound being so integrated, and how we're learning more and more about how those two senses in particularly have a marriage and connection. I am admittedly becoming a little bit skeptical about I am a human behavior researcher, and then I also have my neurodiversity and my actually butting up against each other for the first time in my life, where I'm noticing that HCI, we're often taking the approach of like, we're gonna fix your behavior. And like, that's actually mirroring applied behavioral analysis, which is considered a really problematic therapeutic process in neurodiversity community. So that's what the paper that I'm working on right now is really considering like, when is it appropriate to intervene in someone's behavior? How do we refocus on consent in that domain when it's not about like consent to try it, but actually consent to even propose it can actually be kind of harmful to certain subgroups. So there's a lot that I'm processing now, and looking back on my work retrospectively and saying like, oh, like, I don't want to just hack people. I used to say like, we're just hacking people's behavior to help them. And it's like, I don't believe in that anymore, or I don't want to participate in it.
In training that we have for neurodivergent interactions, something like a sensor, just to say, this could be happening in an area, would be interesting to know when you go in, just all the information you can have to diffuse the situation or what have you.
Yeah, no, I've been so I'm thinking a lot about Dr. Joy Bolamwini's Unmasking AI. I don't know if people in this group have heard it. And there's this one thing she talks about where, so in a lot of our machine learning, as we know, we have like these really skewed and biased data. So her original solution to this was like, we need better data sets, right? And so let's go get data and get faces for facial recognition from more diverse people, which actually led to all this like predatory surveillance culture and all these other problems. So it's not that, I think these are all great ideas. I'm just right now in a place where I'm processing what I just did for 5 years and saying like, okay, like, where is the line? Because then Dr. Bolamwini's original solution was, let's get more diverse data sets. And now she's like, no, let's just not design this. And I have never really been proposed like, no, like not everything is a solution for design. I work with environmental product design students and they learn design thinking. And so many of us are saying that. And one of my students said, well, you know, like if I have enough empathy, I can become an expert of anything. And I was like, I don't believe that actually. And I think we say that a lot. And I'm questioning it. I don't know why. This wasn't part of my plans talk, but since we're having an engaging conversation, and I appreciate these questions because this is where I am at. Like, if we start adding these sensors and this data, like, how do we always know? And in a public setting, like that somebody wants their stims to be observed. Like, I do, but other people might not, and it becomes tricky in that situation. So those are some of the quagmires that keep me up at night. Yes.
Do you see yourself moving towards autoethnographic work? Is that like something that's happening with you?
Yeah, the paper that I'm working on is a fairy tale from first person perspective. And it's complicated. So I have a lot of digital illustrations, and I've done a photographing of myself stimming for the first time in my life, which was a really interesting process for me. Just looking at something that I never see except from within my own perspective. I've never let anyone photograph me doing that behavior before. And so and this fairy tale where inspired by Liz Jackson's concept of a neurodiversity, disability dongle. Has anyone heard that term? So the disability dongle is this idea that we're going to design the thing to fix you. Some examples of a disability dongle include a wheelchair that goes upstairs, and wheelchair users are we don't want that. We have no interest in that. Please stop making these things for us. No. The other one is a shoe that guides visually impaired people. And they're we have a cane. This works great. We don't need anything to replace this already optimally designed thing that actually is a source of pride for us. And so they argue, as Jackson argues, all of these products we are making are fairy tales. And so I was very taken by this idea, and I'm let's write the fairy tale where instead the fairy tale in mine is instead of the dongle solving all my problems, the dongle does nothing. It just turns on red and green. And social people, people come and help me clean my house. I have a friend who comes and shows up for me. And we talk about all the ways that beyond our design practice, we have to engage to solve these problems. So when we're talking about socio-technical problems, we require socio-technical responses. And that's what I'm working on now. So my undergraduate work is in philosophy and poetry. And I guess that specter was I tried to shove it in this shoe, but it's coming out quickly. So we'll see what happens and where my work goes in that domain. But I still want to make and build. And the other part of me is no, let's solve these really important problems and help people. And I'm just in a pause where I reflect upon what that really means. Yeah. So yeah.
Yeah, so I was thinking about the self-robotics aspect, and which is inflating and deflating. I was thinking if you've tested, for example, people having the similar perception of being calm when there is not necessarily movement, but instead there is I don't know, a warm breeze or a cold breeze going through their surrounding or the hand, that if they felt the same, the same feeling.
I haven't tested that with my system, but I can speak a little bit to that from an environmental psychology perspective, which is that for a really long time, we were to help people feel calmer, let's make the environment more neutral, less chaotic, we're going to take things out of it. And what we came to discover was that actually many of the times we're actually understimulated in interior environments, and they don't have enough rich sensory data that's varied and diverse. And that's what's so different about a natural environment versus an interior one. So I love that what you're bringing out is that we often have this assumption that by taking away from the environment or making it more neutral or basic, that we're going to make it more calming and less overwhelming. But actually we're often overwhelmed because there's not enough stimuli that's activating us and keeping us regulated. So what you said made me think about that. And also this, just to plug in some more neurodiversity stuff. We often hear when people I get a lot of calls of people we want to design a sensory room. And the first assumption is it's going to be calm. Everything's going to be blue. We're just going to make it super chill. There'll be a bubble light in the corner. And it's actually we have sensory seekers and we have sensory avoiders. And that's not just oh, you're a sensory seeker, you're a sensory avoider. I might internally be auditorily a sensory seeker and olfactory wise a sensory avoider. And then to add even more complexity that this is happening differently for different senses, it's happening differently based on my personal experience of overload at any given time. So when I am very stressed, I have a very different capacity for stimuli than I do when I'm not stressed. And so I think one of the biggest things we can do is to stop acting like these are static traits and understand that they are very diverse states, and that they are very different across people and internally as well from day to day. Yeah.
I don't know if you talked about the participants in your previous self-robotic studies, but I'm wondering if you are thinking in the future, in your future work, differently about recruitment or how your users study design will be based on working with different neurodiverse folks.
Thank you for bringing that up. And I'm sorry I didn't actually address that limitation. We've been testing these at populations broadly and with no recruitment for neurodivergent populations. And that's absolutely a primary responsibility that I feel moving forward. And yes, very, very, very important point. Thank you for bringing that up.
is there like a way that you're thinking about user studies might have to shift that you suspect or?
A lot of it's convenience sampling, I'll tell you that, that SONA system of just asking people and giving them some credit is very convenient, but definitely probably is not going to cut it moving forward. So I'm really interested in co-design. I am particularly interested in FEM representation in autistic spaces and late diagnosis, but just because like I understand that perspective, but I'm also very wary of the fact that I have many intersecting privileges within that representation and how to make sure that like my research doesn't start self-funneling and then creating more airspace on the people who are already getting the most airspace, especially on like neurodiversity TikTok and stuff. So like, and I'm not hating on neurodiversity TikTok, but those are my people. But like, I think there's clearly the algorithm prioritizes certain types of voices and many of those mirror my own representation. So that's something that I have to work through, and I don't know that I have the perfect answer at this stage. Yeah. Sorry, there was a lot of topics I covered here, huh? Yeah.
Just throw one really direct question.
Yeah.
This concept of neurodivergent is a broad concept. It really has to do with societal norms and sort of physiological norms. I'm just curious if you know of anybody that is doing research, sort of fundamental research on neurodiversity and how that neurodiversity, changes and goes in flux, biologically, sociologically. Those are big, broad topics, but I think there's a gold mine there. I mean, intuitively, if you think it through, we're learning more about our biology and our psychology and our sociology. Are there any, centers of excellence in this regard? Do you know of any, programs at any of the top 20 schools? Just curious about the.
Just to clarify your question, are you asking like about tracking rates of diagnosis and stuff, or rates of existence in the population and how that's changing over time?
Identify broad sort of segments, broad behaviors, sociologically, physically, anything that's gonna create if you will, a virtual map of, our species and how we do things.
Yeah, so it's actually a landmine question. It talks on a lot of fish. I'm like, we don't have a ton of time, but so there are a lot of people who are looking, especially at autism. I think autism gets a ton of trying to map. For example, Simon Baron-Cohen, the expert of autism. We don't appreciate his research, if you can tell from my tone, is mapping and trying to epigenetically show where autism is. But there's a deep history in our culture of mapping and being identified and having that used against us. So the reason that Asperger's is no longer used as a term and why we've collapsed to autism spectrum disorder is because Hans Asperger was actually collaborating with the Nazis. And the idea of Asperger was that these are people whose functioning and behavior means they are worthy of life, whereas people who are not Asperger's but autistic are not. So many autistic people, and again, that's not representative of neurodiversity overall, but just from my perspective, many autistic people are very wary about the new research. That's one, focusing on behaviors. Most autistic people will argue, like, please don't focus on behavior, focus on motivation. And that's one thing that people are arguing for, which for me, when I'm like, geez, I got human behavior and design, like what do can I just change human motivation? And like it's a complicated thing, because at the same time we do want to change some behaviors. Like there are behaviors that are self-harmful or can be harming other people, and so I don't, there's a complexity. But in terms of identifying, mapping, locating, and tracking, there is, I think, a lot of justifiable resistance to that, and a lot of people speaking out about the new research coming out from Simon Baron-Cohen on the epigenetics of autism.
I appreciate that perspective. I should have probably premised my big picture there as there's so many positives about not human behavior, but human predisposition, capabilities, whatever you want to call it, that can be positive in a social context. That just simple concept, ideas, people who form ideas with broad swaths of emotional intelligence and sort of seeing things in a different way than a large part of the population, that if if you will, that diversity of thought becomes a high value thing for the society. Those are way different than the thing you mentioned.
Yeah. Yeah, and there's some exciting stuff where like people in autism community are starting to identify certain sub-phenotypes and different like sub-identities and neurotypes. And I think all that stuff's really empowering and maybe more in service of that.